Hello there. This video we're going to look at a forecasting error method called MSE, mean square of errors. And basically where you can use it is where data points and differences between forecast and what actually happened are so close together that you need to be able to separate those really close measurements of error so you can see some details. So what you'll find is the further away the actual is from the forecast, when you square it as you see in the forecast here, it tends to magnify the difference a bit, which also gives you a little bit of a sense of what the impact is of missing by a little bit more. So let's go to another page here and put some math together here and walk you through it. So let's do actual and forecast in two columns. Let's say forecast is 10 for 5 periods. And the actual, let's keep it simple so we can see the point here, 8 and 12, 9 and 11. Let's do another one here, 7 and 13. Okay, and this is strictly for purposes of explaining where you can see the difference of being off by a little bit more each time can impact. So the forecast and the actual 60, so there's no bias there, but the formula says sum up the errors for each period. So let's do the error here first, -2 and 2, -1 and 1, -3 and 3. And it says take the errors for each period and square them. So I'm just going to call it E squared, 4, 4, 1, 1, 9, and 9. And then it says sum them all up. So I've got 4 and 4 is 8, and 9 and 10, 10 and 9 is 19, 28. So sum those all up and then take 28, divide it by the number of forecasting periods, which is 1, 2, 3, 4, 5, 6. And I'll grab my calculator. Well, we can do it longhand here too. 6 goes into 28 4 times, 40 left over, 4 left over, roughly 46.7, or excuse me, 4.67. My apologies. So roughly 4 2/3 is the error. So that's a measurement when the variation, the amount of error is real close. Probably would use it more when you get not so much differences by 1 like you see in the error column, but if you're off by 0.01 or 0.02 when the differences are really close, when you square them, then you can see the magnitude of difference. But you can also see when you go from missing by 1 to missing by 1 more at 2, and missing by 1 more even, missing by 3, the magnitude is different each time. So it makes for an interesting discussion in supply chain to talk about, well, what is the impact when you miss incrementally by 1 more? So fundamentally, the formula for mean sum of errors is equal to the sum of errors, actual minus forecast, squared, divided by number of periods, or in math terms, n. Okay?